Okay, first things first, I'm going to open up Q ground control. You can see in the top left corner when I open it that it's going to be disconnected. And then I'm going to open up Gazebo-Classic simulation, and that's going to interface with PX4, and we're going to be able to run a script that tells our simulated drone what to do. So we're hoping that we can extend this to hardware in the future. And right now we're just kind of seeing what sort of functionalities we have in MAVSDK. So in this script, we've implemented a geofence. We've also subscribed to telemetry data. So we're getting telemetry data and plotting that to compare if the Q ground control and our simulation agree with each other on the path that the drone took. And then we also transitioned to fixed wing and transitioned to multi-copter. So those are two VTOL functions that we found could only work in the C++ API of MAVSDK. In the Python version, they do not support it yet. So as you can see, the geofence has correctly been uploaded to Q ground control. So anything that we add in the script that's mission related will be relayed to Q ground control, and there will be a log of it there. So that's a nice functionality that we have. So we're going to start the simulation. So essentially what we've done is have the VTOL take off, and now it's loitering. So it's just orbiting around a point, which is the launch location. After a little bit, we're going to send it down south to a point near the edge of the geofence, and then we're going to have it transition to a multicopter once it gets there, and then transition back to a fixed wing and return to launch. So we're going to watch that happen.
Return flight mode.
After we land, we have the script plot the data that we subscribe to from the telemetry plugin, and then using that plot, we're going to compare it with our route, and we see that it's identical. Okay, so just taking a look at our script, you can see that we subscribe to the telemetry information, and that's what we use to plot. We also created a geofence, and we're able to send commands to the drone just using simple commands, especially for the fixed wing transition. That was a very simple command, just one line. This is where we sent the drone down south, and then we called the return to launch command. And as you can see at the end, we use GNU plot functionality to plot our data from the telemetry plugin. One last thing I just wanted to show real quick was that I was able to get a DualShock 4 controller to basically control the drone in SITL. So I'm hoping we can quickly use mappings, kind of like we did with the DualShock here, for other controllers, and be able to have all of our inputs that we need to control the drone, and take manual intervention if needed.